Let's consider some issues we might have with IP version 4 static routing. Number one, when we're configuring that static route, and we use the IP route command to do that, we'll do that for you live in just a moment. When we're giving that command, instead of specifying a next hop IP address as part of that command, maybe we're specifying an egress interface, and that can lead to poor performance. Maybe we're using a feature called proxy ARP, and that could generate extra load on the router. It could open up a security hole as well. Or maybe that static route that we configured has a higher administrative distance than some other routing source. Let's get going though by taking a look at how do we configure a basic static route, and then we'll dive into the troubleshooting. Here on screen we see the syntax for an IP route command. In fact, let's do this. Let's go out to the live interface right now, and using this topology, I'm going to configure a static route. I'm going to go into global configuration mode here on router R1, and let's say that I want to create a route to get over to, let's say, router R3. We've got interface serial 1/0 on router R3. It's got an IP address of 10.1.2.6. Can I ping that right now? I don't think I can. Let's try to ping 10.1.2.6. No, I'm not able to ping that right now because I have no route to it. After the pings timeout, I'll show you. I'll do a show IP route, and you'll see that there's no dynamic routing protocol configured on this router. It's I just know about locally connected routes and interfaces. What I can do though, because I'm sort of a stub router over here, I'm not really a transit router to get anywhere. I can configure a static route to get to this network between R2 and R3. Here's how I can do that. Let's go into global configuration mode, and I'm going to say IP route, and I'm going to specify the destination network, and that network is 10.1.2.4, and we're going to have a subnet mask of 255.255.255.252, and now I could specify, let's use some context-sensitive help, I could specify an egress interface, or I could specify a next hop IP address. Now, I'm going to choose to use a next hop IP address. That's normally what we'll want to do. I'm going to say my next hop IP address is going to be, let's see, fast Ethernet 0/0 in router R2. We'll say it's 10.1.1.2. And more context-sensitive help shows us that I could specify an administrative distance. The default administrative distance for a statically configured route is 1. Remember, the lower the administrative distance, the more believable the route. I'm going to leave it at the default though, and let's see now if we have a route in our routing table to get to that network. We do. We've got this statically configured route. Can I now ping the serial 1/0 interface on router R3? Let's try. Let's do a ping to 10.1.2.6. And this time it's successful. We went in and we configured a static route. That's the basic configuration of a static route, but let's take a look at some troubleshooting issues that could arise when we're doing static routing. Maybe we have a poor network performance. How do we know that? Well, we might give a ping command and we notice that the round trip time for that ping is unexpectedly long. One thing that could be going on is when we've configured that static route, we're pointing to an egress interface rather than a next hop IP address. In the example we just did, I used a next hop IP address, but maybe we specified an egress interface, and it's a broadcast interface. It's maybe a fast Ethernet interface, and that could lead to some performance issues. That could generate an excessive number of ARPs, and that could result in poor CPU performance. In fact, Cisco iOS even gives us a warning if we configure a static route like that. Let me show you. Let's go back out to the live interface. Let's go over to router R4 in our topology. And on router R4, let's do a show IP route. I don't think I have anything configured here. No, I don't. Let's configure a static route, and let's use the egress interface in that static route command. I'm going to say IP route, and I'll make a default static route. 0.0.0.0, 0.0.0.0. Now, instead of specifying a next hop IP address, I'm going to specify an egress interface. Let's use, looks like fast Ethernet 0/0 is a broadcast interface on router R4. I'll say, let's go out of fast Ethernet 0/0. Now, that's a valid command. That is accepted by Cisco iOS. However, it tells us right on the screen, if this is not a point-to-point interface, and it's not in this case, this may impact performance. Yeah, we want to avoid pointing to an egress interface, especially when that egress interface is some sort of a broadcast interface. So how do we fix this? Well, we can take a look at the IP routing table. If I do a show IP route, we're going to see that this statically configured route is pointing to an interface as opposed to an X-top IP address. The way we would fix this is we would go in and we would negate, we would get rid of that, static route statement. Let's say no IP route 0.0.0.0, 0.0.0.0.0, and it was fast Ethernet 0/0. Let's get rid of that and let's put back in a default static route that's going to point to a X-top IP address. Let's say we're going to be pointing to 10.1.4.2 as an example. And now we'll do a show IP route just to confirm that. And that looks much better. We're pointing to a X-top IP address as opposed to an egress interface.